This is the CloudSec 12-step, and what we're going to be covering today is I'm going to go over a brief overview of cloud. I don't necessarily know what your backgrounds are with cloud, who has implementations in the cloud, who's done prototyping in the cloud, or who is totally new. So I want to cover some of the overview stuff for what cloud computing is, go through the 12 steps, and then make some recommendations. So just a quick show of hands, how many of you in the room actually are in the cloud, either personally or your company? And is that software as a service kind of thing? One hand, okay. So how many of you have a credit card? Pretty much everybody? Yeah. So everybody in here who has a credit card could be on the cloud right freaking now. It's gotten to be that easy. And we actually got started doing cloud research. I've been in computers since 1987. I started coding professionally. I've been an analyst with Securosis now for about 3 years. But before that, I was a CTO or VP of engineering at several different startups. Some doing security products, some doing financial products in a secure fashion. So that's really my background. We were contacted by the Cloud Security Alliance about 2 years ago to write the cloud security training program. And so we've spent the better part of the last year going through different cloud models and figuring out how the heck to secure them, whether it be Amazon or Rackspace or GoGrid or what have you, and writing them training curriculum. So a lot of what you're going to see today comes from that practical experience. We also run portions of our business in the cloud. We have an Amazon account, and I use it solely for the purpose of going to Starbucks. I have a free tier AMI, a set of certificates, and when I go to Starbucks, I create an encrypted VPN up to Amazon, and I can run all my sessions that way and not worry about fire sheep or getting sniffed or getting hacked. What do you think my bill per month is? Because my 7 business partners and I use this Amazon account.
You turn it off at night?
No.
$72.
58 cents per month. So, you know, when I came up with the... Yeah, no, seriously, it's 58 cents a month, and that's just simply because of some of the network bandwidth. And it dawned on me when I was putting together the slide deck, and then the reason why I called it, you know, the CloudSec 12-step is that you got to realize that you are powerless to stop your company from going to the cloud. You will be going there. Just what type of cloud are you going to be using? You know, what is the model that you're going to be approaching it, and what portions of your services are going there? It's too plentiful, too elastic, too easy to use, and too cost effective. Even the government organizations I talk with are moving, and they've got tons of compliance regulations that they worry about, but they just use a different form of cloud to take care of those compliance regulations. I'll go more into that later. So what is the cloud? I mean, most of you are going to know it because you've heard about Salesforce or use Salesforce or whatnot. You might use Netflix. Obviously, that's another consumer example. But you know, basically what it is an abstraction of infrastructure. The very first cloud, as I know it, came into existence because Amazon realized that on any given day, they only needed 1% capacity, but for that Christmas week or month or whatever, they needed, you know, 100% capacity. And so for the rest of the year, it was all wasted. So the entire model was to abstract the infrastructure and abstract the resources and resell that to other people who could take advantage of it. And it needs to be dynamic and elastic. I need to be able to sign up for it. If I need more resources, I can scale up. If I need less, I scale back down. It should be able to do that automatically for me. Resource democratization. I'm not going to have an admin go out there and take a couple of servers and put it in a rack and reconfigure them for you. No, it's got to be elastic. It's got to be dynamic in that way that they can come in, sign up for it, get the resources that they need. It's a pay-as-you-go model. You use resources, you pay for them. You shut those resources down, you don't pay for them. So this is the NIST model for cloud computing. And I'm not sure how good the contrast here is. So there's really 2 things I really want to point out. So I've kind of just covered the top piece about what the cloud is. The 2 pieces I want you to pay attention here are the service models and the deployment models. So the service models, software as a service. You're literally buying an application that sits out there. You do very little except put your data in it and manage a couple configuration settings for how you're going to use it, accounts and so forth. You're familiar with it, but today, most of you, if you're here at OWASP, you're not particularly interested in that. It's the other 2 models that I think you're going to be most interested in long term. So infrastructure as a service, basically you are buying infrastructure, you're assembling infrastructure just like you would in your own data center, except it's out in the cloud. And then platform as a service, and I'll go into a little bit greater detail on what that is. You get some additional infrastructure and applications given to you, pre-packaged, all ready to go. You use their API, you use their messaging queues and so forth, but you are buying a platform. So in that type of model, you're really sharing the responsibilities of administration and orchestration with a provider to varying degrees. So if you're software as a service, you're touching on almost none of the administrative responsibilities. Infrastructure as a service on the other end, most of them. How many people in here work for large enterprise? Oh, almost half the room. Okay, so most likely you're going to be doing private. Right now, almost exclusively the enterprises I talk to are either in a hybrid mode or in a private mode. And what that basically means is that they're either contracting with a major hosting provider, cloud hosting provider, to do a private cloud on private infrastructure, or they're doing a private cloud on public infrastructure, but it's purely segmented off through the software and the management plane within that hosting provider, so that nobody else can touch it with except your own internal infrastructure. And that's where we get into the hybrid model, where you have your traditional IT, and it just uses some resources in the cloud to do testing, business analytics, maybe some quick search stuff, scale it up, use the infrastructure, and then shut it back down. And then what we see most often in government is community. So the IRS and the Social Security Administration and some other government agency will share a private cloud infrastructure, but since their regulatory requirements are very the same as far as data privacy, they can share that no problem. They don't worry about the multi-tenancy issues that are common within public cloud infrastructure. So, what it's not. And I know there have been a couple high-profile people in security who have said, cloud computing really is just nothing more than mainframe for the 21st century. That's bullshit. Not true. It's not. It's not cloud in a box. I know Oracle's trying to sell you cloud in a box, but it's not cloud in a box. There are a couple reasons for that. Scalability, self-service models, elasticity, those are many of them. The other reason is this. This is part of the cloud. What we're going to be talking about here today is the service side of the cloud, meaning the server infrastructures that support the applications, because I'm assuming that's what you're most interested in, but this is the other half of it, and that's not a mainframe in a box. And it's not virtualization either. Now, every single cloud provider out there uses a virtualization technology, and in fact, the measurement unit that all of the cloud providers use is a machine unit, much like this, the virtual machine image. So while all the cloud providers use it, the cloud itself is not a virtualized box. So this is a taxonomy. Chris Hoff did this a couple of years ago. If you're interested in the taxonomy and what each individual software as a service, platform as a service, and infrastructure as a service really involves, please go find Chris Hoff's. It's called the Frogs Who Desired a King. It breaks down the taxonomy for cloud in a brilliant way and gives examples. Here I'm just going to kind of skim over it a little bit because I think there's some interesting examples. You're going to be hearing a lot about infrastructure as a service in this presentation. Examples include EC2, Amazon's EC2, Rackspace, and GoGrid. You assemble the infrastructures you need. You put machines, images, caching together, memory space, disk, what have you. Platform as a service, usually some application. The most common what you're going to see for platform as a service is things like database as a service, database.com. SQL Azure really should be considered platform as a service because it's operating system, it's database, it's application, APIs, messaging queues, and that sort of thing. Things, the infrastructure that you need to build an application on top of. And then finally, software as a service. I doubt anybody here is going to be programming for this. So what are the security implications? Variable control. You don't necessarily control the infrastructure, either in infrastructure as a service or definitely not platform as a service. Variable visibility. I'll give some examples of this in a minute. Variable resource availability and variable simplicity. All right, so you can't test in the same way. Why not? Amazon's not going to let you pen test their site. Not going to happen. Rackspace is not going to share log files and application logs with you because it's a multi-tenant environment. There is no span port to plug your IDS into. So this is a virtualized network. Some of it may run over a piece of physical hardware. Some of it may just be memory cache transfers. So you're really limited in what you can deploy. We've done security now for a long time with traditional IT, and we have specific models for how we deploy data collectors, how we deploy security solutions, and the cloud does change it. It doesn't change it radically, but everything across the cloud changes a little bit. And that's one of the problems with doing a cloud security course, is that I need to cover a little bit everywhere. And so I've got a lot of slides that I'm going to go as quickly as I can. Please save questions to the end unless it's like burning in your mind, and I'll try to take one or two, but I'm going to try to keep moving along here. So you will notice today that I'm going to focus on PaaS and IaaS. As I said, you're not programming SaaS environments most likely. I'm going to try to take a development-oriented view here as much as I possibly can. Most of these examples I'm going to give you are on Amazon EC2. It's not because that's the preferred method. In fact, I will encourage all of you to go out to Rackspace, look at OpenStack, look at the OpenStack movement. A lot of you might prefer that to develop open applications. It's just that EC2 was a little more accessible for me because I already had an account, so it was easier to get screenshots. It's cheap, and it was just faster for me to put the slide deck together. And I'll probably concentrate on public and hybrid deployments, certainly within the encryption and key management stuff. So the program itself, I'm going to start out with application security. All of the aspects of application security across the Nest LLC, there will be minor tweaks and changes across the board. So architecture. There are things you're going to want to lever in any application you put into the cloud. It's a native service-oriented architecture. You want to be able to take advantage of that because you want the application to scale up or down and take advantage of the resources you have available. But if you were Netflix and you were dispersing your application across multiple geographic zones, you've got to have something that's going to allow for federated identity. Within your own service infrastructure, you're going to be communicating with certificates. So one database server talking to a different application is going to validate itself through certificates and other cryptographic means. And your threat and risk analysis is going to change because in infrastructure as a service, you still have a partner, the provider. They will be providing some services to you, and platform as a service, once again, they will have a big piece of the puzzle. They will manage that infrastructure. You will be managing the application and everything outside of that. So to kind of hammer that point home, in your traditional IT infrastructure, everything's in-house. You own everything. You shield what you need to shield, and you push out to the public what you need to push out, or with your internal organization. With infrastructure as a service, not quite the same. Your architecture and design is still in-house. Deployment can still be in-house. Testing, maybe, maybe not. I'll get more into that in the testing session, and then the production environment is fully externalized to the cloud. Platform as a service, a lot of that infrastructure is going to be owned and managed by the provider, right down to the APIs. So these trust boundaries differ. How you're going to secure your provider or get your provider to validate that they're giving you security, you've got to work that out with them. Every provider is different. So I had a couple slides on threat modeling. I realize I don't have time to go through them all, but you will be threat modeling your cloud deployment about how the applications are deployed, which components communicate with other components, how you're going to threat model the provider hack, and these have happened. Cloud deployments have been hacked, or they have had failures within load balancing or other sorts of tools that are supposed to segregate and keep users in a multi-tenant environment separate, and they work until they don't, which means occasionally they fail. So design for threats. Any application that you're going to deploy in the cloud, you need to reconsider who owns what and how it's going to be secured. And this is just a basic breakdown of the things you want to consider for different types of threat. So for example, the spoofing attacks, authentication, for elevation of privilege authorization, and I'll dig into a little deeper in that in a couple slides. So I'd already mentioned what you can test. You need to consider that. You can't really fuzz test on a live environment that's in the cloud. It's not feasible. The beauty of that is, though, that you can leverage infrastructure as a service to actually give yourself a private cloud and do full testing and very closely mimic a production environment. But all of these things about multi-tenancy and about different threat models you need to take into account. So I think I've gone into much of that. So within the slide deck, I'll put this up. This is kind of a handy chart about how to approach some of the application architecture issues and where to put your resources. I know it's a little bit small and hard to read, but we'll make the slide deck available so you can check it out after the presentation. So identity and authorization. There will be a couple of very good presentations, undoubtedly, on identity and authorization for cloud services during the course of this week. Obviously, for identity, the things you're worried about is registering users, both internal and external. Propagation of those users, especially if you're using a cloud service that it goes across multiple cloud boundaries. For example, Rackspace or an Amazon is going to have different deployment zones. One in the east, one in the west, one in Europe. And if you want identity to spawn across those different regional boundaries, you have to do it. That's up to you. Some of your platform as a service provider will take care of that for you automatically on the back end. User management, deprovisioning users as necessary, and auditing the activity of the creation of accounts and so forth. Access, this is all pretty traditional stuff, right? You've seen this before, but how are you going to go about it within the cloud environment? Are you going to deploy an LDAP server? Maybe, maybe not. What we're seeing is that the vendors provide pretty good infrastructure for most basic cloud deployments. If you're fully in a private cloud, you can deploy traditional LDAP services, Active Directory, what have you. If you're in a hybrid model, meaning you're in traditional IT infrastructure, communicates through a VPN tunnel up to the cloud, you can still take advantage of what you have today and have those cloud services link in with the traditional existing IT infrastructure. That's important because that keeps your costs down too. Single sign-on. This is really where a lot of the application developers I'm speaking with are moving, and they're using things like SAML. And really SAML is there to make sure that you can federate identity and single sign-on across a number of different environments. And so most of the applications I'm seeing nowadays, built for either web applications or cloud service applications, are being built with SAML in mind. And I'm not going to go into a great detail there in SAML. I'm assuming that if you're a programmer, you know about SAML already. Same thing with OAuth. Once again, the ability to avoid having credential propagation all over the place. OAuth allows us to make an assertion and have that assertion be validated through key exchanges as opposed to sending a username and password. How many of you are here are aware that when you sign up for an Amazon or Rackspace account, you get a certificate? Okay, you don't get username and password. That's important. You'll see why in a couple slides here. So once again, options. SAML is the emerging standard right now. OAuth, definitely widely used. OpenID, not recommended, not really particularly secure. It's just for ease of use, giving people web app access, not really secure, but convenient. And then WS Federation for Windows stacks. One of the things that you might notice if you set up accounts on many of the providers is that, there's probably a bias in my slide deck here, you're going to see a lot more Linux in your Windows than any of the slides. For whatever reason, when you start up a Windows account, it can take 25 or 30 minutes to spin up a Windows box in the cloud. I have no idea why that is. I can't figure it out. So almost all of the training that we've been providing has been on Linux-based systems because they come up in 2 or 3 minutes. And when we're running a class or you're trying to do demos or you're trying to spin up stuff quickly, run a test and spin it back down, that's a big deal. So pure bias on my part, I guess, because I'm lazy and don't want to wait around. Code analysis. I really had trouble putting this number 4 in here. The reason I put it in here is that if you can't do image validation, if you can't validate the machine before you're going to deploy it, or you cannot do dynamic web application testing, really better be doing binary analysis or white box testing. If you have the options of validating the stack, and that's later in the slide presentation too, it's less required. I mean, obviously the cloud security guidance and most of the people who founded the Cloud Security Alliance recommend it, but use your best judgment. So testing. One of the things that I've been able to do is to actually use private clouds to test. completely mimic an internal testing infrastructure, spin it up very quickly, run my test, pull the results down, shut the whole infrastructure down. I don't have to buy, I don't have to provision. All I got to do is set it up and run it. And since it's your own private cloud, you don't have to worry about others actually getting access to it. So I strongly advise, if you're going to do testing of web applications, do it in a private cloud. You can set it up on Amazon in public infrastructure, or you can retain, if you're in a larger company, you've got data security issues, you can contract with one of the larger providers and they will segment off an area for you, and you can do a private cloud on private infrastructure. But it is very handy to be able to move good production quality data up into the cloud, test very quickly, and get it back out of there. Fuzzing testing is also possible in this type. You can do full-on dynamic testing because you're not actually testing from outside into the cloud, but you're inside your own private area within the cloud. But you also want to make sure that anybody that you contract with get the service level agreements. What does your vendor allow you to do? Will they allow you to do a vulnerability assessment? Will they allow you to do a partial pen test? Will they give you the results of a pen test or do some of that for you? There's lots of leeway for what you can negotiate with the cloud provider, but you have to do the work because they don't want to do it. So, but most of them have provisions for you if you sign up for an account that they will give you some of that information. Find out what they do, find out what they can do, figure out what the delta is, and make plans to accommodate for your own cloud infrastructure. And I threw this in kind of as an example because some of the cloud providers allow you to do vulnerability assessment, but that's about the extent of it. They're not going to let you do fuzzing and a lot of other types of stress testing. So app protection, and I've got a couple other slides in here for some of the audience members, but to start with, a lot of this is going to look like exactly what you do today. There might be a firewall. There's probably going to be a WAF. There are some new technologies out there that allow you to take another machine image embed within your own stack honeypotting. So it'll leave small traces of what looks like a vulnerability. If it gets attacked, you know you're under attack and you can take countermeasures, either through a WAF or through some other technology. Firewalls inherent to the cloud providers. So once again, service level agreement, find out what your vendor is going to filter. If you're on infrastructure as a service, most likely you're going to deal with this on security zone and IP filtering. I'll get into that more later. If you're on platform as a service, varies from provider. And I threw this in there for one of our audience members because this is what we have been seeing in most of the literature, right? Firewalls and SSL, firewalls and SSL. Not so. This is not going to protect you. So let's move into information security. This is a piece of guidance that we had created for the Cloud Security Alliance. It doesn't really work, but what it does do a good job of it is kind of dividing up all the different use cases for data. Where is it? How is it used? Where does it go? How does it get stored? And the reason why I actually put it in here is both to let you know that it doesn't work, but also it in almost every single step, encryption is the core value. So you're going to be using encryption a lot for data storage, for data migration, what have you. You might choose to encrypt at a number of different levels. One of the biggest threats that we ran across when creating the guidance or the training class was we realized that if you're taking a backup in the cloud, it is trivial. You log in, you make a snapshot, it's done in seconds. Creates a copy of your entire infrastructure or your entire database or just a volume, whatever you want. But it's also trivial to press another button and have that public. And then press another button and 30 seconds later it's moved to a different cloud. You could quite literally, if you have a compromise, lose your entire infrastructure in a matter of seconds in a scalable, high-performance, elastic way. Encryption is your friend. The question is where you're going to do it. Obviously, you're going to do it if you're moving data up to the cloud. So there are SSL capabilities for every single cloud provider that's out there. How you enforce rights management, probably going to be through certificates. The data that you leave there can be stored in a number of different ways. The two ways we see most commonly, like a TrueCrypt volume encryption, or transparent encryptions like a Vormetric on the file system side, or like a built into some of the databases like IBM and Oracle on the database side. And then once again, like many things on the internet, incriminating photos and what have you, data lives in the cloud a really long time. It's redundant because if Amazon loses a server, they want to make sure you don't lose data, so there are multiple copies out there. And they do a great job of, shredding old disks and so forth, but just to be sure, a lot of the people we're talking to in enterprises are looking at crypto shredding as opposed to data, eradicating data through scrubbing disks. So they simply, at some point in time, will throw away the keys on older data. That's becoming the security model. So once again, where you can actually deploy application layer is probably the most secure. You're not worried about where the keys are going to be used or stored as much, and it's much easier to be able to control what gets encrypted with which key at a very granular level. It's also a pain in the ass to code. So what we see most often, as I said, transparent forms of encryption, either at the file system layer or at the database layer, and once again, simple volume encryption. And these are the types of things we normally will teach in a class because it's relatively easy to set up a volume encryption, test it out, and get it to work. Every single cloud provider I've been on so far, it works beautifully. So where to put the keys? This is a problem. So you'll notice that a lot of this presentation is making the assumption that you guys as developers are going to be out there prototyping applications with or without the support of your organization. So you're probably going to do things quick, fast, and easy. And we see a lot of developers put some code out, test it, and they leave the key on the volume. So it's right in the machine image, and they take a backup because they're putting code out there and they want to make sure that they've got a backup. Well, wherever that image goes, the key goes with it. So if somebody else starts up another image of what you've stored out there, they have the key and can get into the volume. So it may sound trivial, but it's actually a really common problem that the key gets stored right on the disk. So you want to look at some sort of a key management service. The infrastructure providers will actually have some key services for you that are built in. The platform as a service providers usually have APIs for this. You can use key servers, commercially available key servers. So most of the HSMs nowadays are setting up APIs so that you can continue to leverage through your own VPN your existing HSM services for key management, and just simply link them up to your cloud services. Once again, leveraging existing infrastructure. Or there are other companies that are producing pre-built AMIs so the machine image already has the key server set up. So you bring it up, you tell it which instances are valid, and it does all the key negotiation for you. And this is important because you might bring up 9 machine images, but only 4 of them are valid. So who is really supposed to be talking to the volume? Who is supposed to be getting keys? Not every single image that comes up is valid. So I think Trend Micro and there's at least like 1 or 2 other vendors out there that have that sort of thing. If you can build the key management on as an independent service. And then of course there are other vendors who provide software key management you can install and use as normal, but you will need to cordon off that virtual machine image and then build in your own application logic that secures new images being brought up. So a couple encryption architectures, do a little bit of a review. You can move this stuff around. And how these pieces communicate with one another, purely defined by you. And this is the simple one that we normally teach. It's quite literally a private instance for the key server, public IP for the app server, and then somewhere in the back end on their private storage piece. So this would be app layer encryption. I put it up here because I figured some of you would be doing that. Monitoring. Where do I deploy the IPS? Where do I do database monitoring? How does the SIM fit in here? Yeah, there's no good answer, and it varies depending upon which provider you're going to, what's actually going to be available. So, what we see for monitoring technologies that go out to secure infrastructure, to secure data, web application firewalls, very common. We're seeing a lot of database activity monitoring, file activity monitoring, especially for SharePoint that moves up into the cloud. Data loss prevention a little bit, usually at different junctions or nodes between. It will look for specific content that's coming through. Most of that's regex filtering, but can also do other types of hash comparisons and looking for sensitive data. Usually I'm seeing this now, people are pulling DLP on the data that moves up into the cloud so they can categorize it and figure out what the sensitive information is, and then figure out how they're going to secure it once it gets up there. Not the best model, but at least they've got some sort of an idea of what they've moved into the cloud. And then and various other service monitors, monitoring database services, application services, deploying your own sensors for event collection. And what's different about the monitoring technologies in the cloud is that they're running on virtualized images. Most of the providers cannot take the stock product that they have and just move it to the cloud. Doesn't usually work very well because the data collectors need very specific things from the operating system. And so they've all had to port or change the data collectors that they install on the virtual machines. That's one of the big differences. Most of the early cloud monitoring technologies, they just literally threw all their stuff onto an AMI, put it out there for you to use, but you had to spend hours actually configuring the thing and getting it to work. Not such a good model. So we're finally starting to see the security vendors, port their data collectors, actually configure their images and make these actually a little bit more cloud accessible. So here's a couple of examples. And once again, this is not an endorsement of any particular technology. This is just kind of, I want to make sure you guys are aware of what's out there and available. So with GoGrid right now, within the load balancers, they've actually deployed F5 as a web application firewall for you. And you could do some custom configuration on this, but it's been built into the infrastructure. You have a more traditional kind of a SaaS model where you are just doing a DNS redirect to be able to do WAF and DLP. So you can just bolt this on anywhere and then redirect the stuff back in your own private or public cloud. Pretty much for infrastructure as a service, an agent-based deployment for database security and database activity monitoring. And the last one down here, pre-built AMIs. Once again, you're basically shoving the monitoring piece into an AMI, configuring it to come up and monitor. You just need to basically tell it which applications and which instances you want monitored. So the third and final portion of the 12-step program, infrastructure. So this is actually, this is one that took me by surprise. It was 2 black hats back that one of the presentations actually showed how easy it was to put a rogue infected Amazon machine image out on Amazon. Anybody can do it anytime. But the key was to getting somebody to use it. So when you go into Amazon or you go into Rackspace and there's public images out there, they're listed. They're listed in the order of popularity and use. So they were writing small scripts to raise the popularity of their rogue application up, and people would just grab them thinking they were safe. Not a good freaking idea, because you're basically launching pre-built malware, pre-built botnet within your infrastructure. It's really important that if you're going to take an AMI, that you find a good one, that you go directly to Red Hat or you go directly to the OS provider and get it. As I said, many of the security vendors now have prepackaged this stuff so you can get a clean AMI. If you can additionally get them to do some sort of white box, code analysis and verify what's actually in that thing, what some of the vulnerabilities might be, that would be an additional benefit. Not always possible. So hardening the stack is really one of the important pieces that you want to do. When you go out, you'll notice that you're going to have the AMIs that you've created, you've configured, you've tuned, and you've saved out here. Most of you, since you've never used this, you're going to come out here and grab a community AMI, and that's where the problem arises. So once again, you can contact almost every single vendor nowadays who's got an Amazon machine image or some sort of a Rackspace image. Deployment stack hardening. So One of the cool things about all of the infrastructure service providers and some of the platform service providers is you can automatically patch and pre-configure any single image that gets launched. They have, right on the launch screen, the place to tell it what to do. So you just give it a script. And it's that simple. Now I've got both of these enabled here, not one commented out, but I mean, you can either update or upgrade to a new version automatically prior to launch. Right there. And you know it happened because you can see the launch screen when it does. In fact, we put messages of the day in there to tell us if the thing actually succeeded or not, so we know if we got successfully patched, successfully updated, right there in the console. It's a very handy way to make sure that as your infrastructure moves forward and expands and contracts, it actually stays up to date as far as patching goes. In addition to that, you can do the same thing with configuration. So for this particular one, what we're doing is we're setting up a MySQL instance to be used on an encrypted drive. So we're just resetting where some of the MySQL infrastructure is. We're using it in the WordPress environment, so we're just moving it over to encrypted volume, changing some stuff around, and then relaunching it. So we can quite literally harden the installation right there at startup time. Very handy. Security zones, step 11 of the 12-step program. These are a really cool feature. Just think about this as your network layer. And security zones are basically a virtual definition of what can communicate in your virtual space. This is how you define certain areas where an application might reside or a database might reside, or a cluster of applications may reside, and then what protocols and what users can go in and out of that. So security zones really define how data flows. It will tell you where you're going to be exposed, your data is going to be exposed, and where your applications will be exposed. So, for example, you can set up a security zone with a web server and with some other application services, define which ports come in and from what locations. You can define when to give public IP addresses and when not. So if you only want one server in here to be able to communicate with other servers in here, you don't give it access to any sort of DNS services or external lookup capabilities. Once again, you can define the ports. So remember, as I said earlier today, when I go to Starbucks, I create a VPN connection up into my Amazon AMI. And that's the only port that that machine image is allowed to do, and it's only going to take one certificate, mine. I can do this from anywhere, but nobody else can. So it's a very, very handy way of setting up the network security very quickly, just a couple lines from in the console of any one of those service providers. And here's might be a little bit clearer example of what I'm talking about. So one of the examples that we give when we train for this, we set up WordPress, we set up MySQL, we only allow them to communicate over one port. And the database is inaccessible except for anything except for over port 22 from my local machine in my house. WordPress instance is publicly available, or maybe only available inside my company, what have you. But this is how I secure the basic network infrastructure. So this gets rid of a lot of need for other types of security, and then I can really tailor whatever monitoring software that I've got to check for threats. And then finally, management plane. As I started the presentation out with, I mean, this is just one of the things that we found to be the biggest problem. The management plane is so freaking powerful that if it is compromised, you can do anything. I mean, all of the data can go. The entire infrastructure can be duplicated and then brought up somewhere else. It's quite stunning. So, kind of an example of the way that the management plane infrastructure for database.com, I just pulled this off because I thought I'd give a pretty clear idea of what they have available. All of these things are available and configurable right from the management console. And unless you set up the security zones and the availability and issue certificates to individual users to kind of segregate this, one person's got it all. That's usually the way that I see it. Unfortunately, that's the case. So in your planning of how you're going to deploy, it's not just a security zone issue, but you need to figure out how you're going to actually realize separation of duties. That goes for Google App Engine as well. That goes for Amazon. If you allow one admin user to have every single access right, or a couple of admins all on the same console, you're setting yourself up for failure. You don't want to put production data out there if you haven't done a proper separation of duties on the management plane. So that's basically the 12 steps. I just kind of wanted to throw a few more things out there, cost considerations. You can design your application to scale without having all the hardware available. It is naturally a service-oriented architecture. Consider that when you are building that resources are not an issue. They're not a problem. But shut down what you don't use. As I said, we're 58 cents a month for our little basic account that we use. And as long as we don't leave volume sitting up and running, as long as we don't leave other servers sitting up and running, test servers, then we get like a $17, $18, $20 bill. So shut down what you don't use, build elasticity into your configuration scripts so that your application can grow and shrink as needed and you don't get overcharged. But go out and use it. I mean, it's really actually quite fascinating. It's kind of fun to do. Some of the OpenStack stuff's really interesting. And so go give it a try. Go spin up a drive and encrypt it and see what the certificates look like and see how you might manage the certificates. Shut it down. You get a bill for $1. You learned about the cloud. That's it.